Okay, it's starting. It's good. Okay.
All right, so we started up the quiz, and now we're gonna take a look at it. Oh, it just said it went live for me. Cool. So the first question, I guess, like question 3, I just consider it the first actual question is: when you're taking a sample of size n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Well, normally, if it's saying that it's right skewed, it's normally kind of skewed to the right.
Sounds good to me.
I mean, like, if you think about it, the answer's kind of there.
Yeah.
But with the sample size of n equals 5, I feel like that kind of plays into a factor. So, I mean, for right now, I will say that it's kind of right skewed just because, I mean, the answer's pretty much there.
Sounds good. What about number?
Or is it more? That sounds. Okay, so I opened up the probability applet.
Uh-huh.
What? So that's what I did. I opened up like the bell curve real quick just to kind of look at it. Where am I? Okay. So if we have a sample size of n equals 5 and it's only 5 bars, wouldn't it be more normal? Because it's not, it's more, it looks almost normal. Or do you think it would be more skewed left?
Well, number 5 has the same n equals 5, but this says when the parent population is normally distributed. So I feel like this would be normal. Number 3 would be right.
And then 100, the sample size of being at 100 would be skewed or normal?
I think it'd be right because it says right skewed.
Yeah, but what were you just reading about the population thing?
What?
What were you just reading?
Oh, question number 5.
Okay, sorry. Like what? When you take it to the shape of distribution means, then that would be normal.
Right.
Yeah. And then
normal.
Yeah, guys, they're pretty much giving you the answers. Like, if it's being evenly distributed out of a sample of 100 or a sample of n equals 5, you know, like, yeah. And then we can just that sounds terrible, but I feel like we use your husband as a resource a lot.
We do, but he's taken this class, so he's just reviewing our answers. Right?
Yeah. And then I would think it would be normal as well for 6.
Yeah.
When would the distribution of means be normally distributed? Well, this is kind of a checkbox one. Data are drawn from a population that is normally distributed and the sample size is small. Well, what do you think that is?
Do you think that ones that are normal?
So when would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small.
You click the ones that all say normally distributed. If it says normally distributed, it should be normally distributed, right?
Yeah. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample over X will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation. So that's talking about the 68%. That's the 68, 95, and 99.7% rule.
Yeah.
If the sample size is large, the sample's mean over X will be close to the, X bar. It's X bar, that's what it's called. Will be close to the population mean. And I used to know what that symbol M meant, like that specific symbol was called. If the sample size is large, the shape of the distribution of sample means will be approximately normal. So which one do you think that would be?
Wait, this one. If the sample size is large, the sample mean will be close to the population mean.
Oh gosh, yay for freaking equation. Let X be a random variable with population mean equals 10 and population standard deviation equals 6. Suppose the sample size is 36 is drawn from this population. So what equation do you think we would use here?
The one from last time, or let me see. I don't know. Do you know this one?
Would we use the z equals?
What is that one?
So it was the z equals standard deviation minus the value.
Maybe.
We might just have to meet for these questions tomorrow.
Okay.
And work on them more tomorrow. So we can pick your husband's brain about them.
I don't think we'll have time. I think we'll just have to do these ones on our own.
Yeah.
He has a couple tests this week.
And I'll go over the videos again, just because, again, like I just kind of skimmed over them. But for the most part, we'll probably just, if you want to, we'll text back and forth and get on Google Hangouts and like message back and forth and see what notes we can compare.
That sounds good.
So, yeah. Other than that, I actually feel pretty good about this quiz.
Wait, where am I?
That's you. I feel kind of good about this quiz.
There I am.
Anyway, but yeah,
okay.
So we'll probably just get together and just kind of compare notes if we wanted to.
That sounds good. Okay.
I will talk.
Okay. What's your last name? Oh, it is. Okay. Got it. Cool. Yep. I had to put your name on the post.
Yeah. You always find me.
I only have you down as Aaron BYU Math in my phone.
I have you as D from class.
There we go.
But I know your last name is Laguna.
Yes. Okay, cool. So I'll post this and then tag you in it or put your name down.
Awesome. Thank you so much. You have a fantastic night.
Good luck tomorrow.
All right. Thanks. I'll need it.
Okay, bye.